On a clear night, if you go somewhere dark enough, you can look up and see thousands of stars. And if you look long enough, you start to feel something. A sense that space just goes on, and on, and on, forever. Most people assume the universe is infinite, endless, that if you could travel fast enough, in any direction, you would simply keep going forever. That assumption is wrong. The universe has an edge. A real, measurable, scientifically confirmed boundary beyond which, from where we stand, nothing can be observed. Nothing can be known, and nothing we send out will ever return with information from the other side. Scientists call it the cosmic horizon, and unlike most mysteries on this channel, this one has been confirmed. Measured, mapped, but here is the part that hasn't been covered enough. That edge is not fixed. It is moving, and it is moving in the wrong direction. Right now, as you watch this, galaxies are crossing that boundary, disappearing from our observable universe. Forever, the number of galaxies we can see is decreasing, not because they are dying, but because the universe itself is ensuring we will never see them again. In the time it takes you to finish watching this video, the observable universe will have lost more of itself. Permanently. This is the story of the edge of everything, and what is being lost beyond it. To understand the edge, you need to understand light. Specifically, the fact that light has a speed limit. Light travels at approximately 300,000 kilometers per second. That sounds instant, but across cosmic distances, it takes time. Real, measurable time. The light reaching your eyes from the sun right now left the sun 8 minutes ago. The light reaching us from the nearest star outside our solar system, Proxima Centauri, left 4 years ago. By the time you see it, 4 years have already passed. Now scale that up to the entire universe. The universe is approximately 13.8 billion years old. That means the oldest light we can possibly receive, light that has been traveling since almost the beginning of time, has been traveling for 13.8 billion years. That creates a boundary, a sphere of observability, the furthest point from which light has had enough time to reach us. Beyond that boundary, light has simply not had enough time to make the journey. We are waiting for it, but it hasn't arrived. Everything within that boundary, we can see. Everything beyond it, we are completely blind to. Here is where it gets strange for the first time. You might expect that boundary to be 13.8 billion light-years away, since the universe is 13.8 billion years old. But the actual measured distance to our cosmic horizon is approximately 46.5 billion light-years in every direction. The observable universe is 93 billion light-years across. But the universe is only 13.8 billion years old. How can we see something 46 billion light-years away if light has only had 13.8 billion years to travel? The answer: the universe has been expanding the entire time. Space itself has been stretching. An object that was close to us when it first emitted its light has been carried away from us by the expansion of space itself, so by the time its light finally reaches us, the object is now much further away than the light travel time would suggest. The light traveled 13.8 billion years. But the object that sent it is now 46 billion light-years away. So what does the edge actually look like? What is there, at the boundary of everything we can observe? In 1964, two radio astronomers in New Jersey, Arno Penzias and Robert Wilson, were trying to eliminate background noise from a large horn antenna. No matter what they did, a faint hiss persisted. From every direction, equal intensity, constant. They had accidentally discovered the cosmic microwave background radiation, the CMB, and it is the most distant thing we have ever detected. The CMB is light, or more precisely, radiation, from approximately 380,000 years after the Big Bang. Before that point in cosmic history, the universe was so hot and dense that light could not travel freely. It was trapped in a sea of plasma, bouncing endlessly, unable to move. Then, as the universe cooled, the plasma cleared. For the first time, light was free to travel, and it has been traveling ever since. In every direction, for 13.8 billion years. The CMB is that light, the first light the universe ever released, and it forms a shell around us, in every direction, the literal wall at the edge of what we can see. Beyond it, the universe exists, but we cannot observe it. The plasma that preceded the CMB blocks our view like a fog that light could not penetrate. So what is beyond the CMB? Beyond the edge of the observable universe? The honest answer is, we don't know. And we may never know. The universe beyond our horizon almost certainly exists. Current models of cosmic inflation, the rapid expansion of space in the first fraction of a second after the Big Bang, suggest the total universe is vastly larger than the observable portion. Some estimates suggest the full universe could be at least 250 times larger than what we can see. Others suggest it may be effectively infinite. But we cannot confirm any of this. Because by definition, nothing from beyond the horizon can reach us. We cannot send a probe. We cannot receive a signal. We cannot even confirm that the laws of physics behave the same way out there as they do in here. The edge of our observable universe is the edge of everything we will ever know. Not because we lack technology, but because the physics of light and time make it permanently impossible. At this point, you might be thinking something reassuring. The universe is expanding, yes. The edge is far away, yes. But surely, as time passes, we will see more. As the universe gets older, light from further away will have had more time to reach us. The observable universe should grow. We should gain ground on the edge, not lose it. That is the logical conclusion. And it was the scientific consensus, for a time. For most of the 20th century, scientists believed the universe was expanding, but slowing down. Gravity, pulling on all the matter in the universe, was gradually putting the brakes on expansion. The universe would expand forever, but at a decelerating rate. Under that model, the observable universe was indeed growing over time. The edge was receding, but our visibility was keeping pace. We were gaining on it. The future looked, cosmically speaking, more informative, not less. And then, in 1998, two independent research teams studying distant supernovae made a discovery that completely rewrote the future of the universe. And of everything we would ever be able to see. In 1998, Saul Perlmutter, Brian Schmidt, and Adam Rees were studying Type Ia supernovae, a specific type of stellar explosion that always reaches the same peak brightness, making them reliable cosmic distance markers. They expected to find that distant supernovae were decelerating, slowing down as gravity pulled back on the expansion. Instead, they found the opposite. Distant supernovae were dimmer than expected. They were further away than the models predicted. The expansion of the universe wasn't slowing down. It was speeding up. The universe is not just expanding. It is accelerating. Something, which scientists call dark energy, is driving galaxies apart at an increasing rate. And this single discovery, which earned its discoverers the Nobel Prize in Physics in 2011, changed everything about the future of the observable universe. Here is what accelerating expansion means for the edge. Beyond a certain distance, known as the cosmic event horizon, galaxies are already moving away from us faster than the speed of light. Not because they are physically moving through space faster than light, but because the space between us is expanding faster than light can cross it. Light from those galaxies, emitted today, will never reach us. No matter how long we wait, the space between us grows faster than the light can travel across it. That light is effectively running on a treadmill moving faster than it can run. It will never arrive, but here is the part that most people don't fully appreciate. Some of the galaxies we can currently see, right now, in our night sky, have already crossed that horizon. They crossed it in the past. We can still see them, because the light they emitted before they crossed the horizon is still reaching us. That ancient light is still traveling toward us, and we can detect it. But the light those galaxies are emitting right now, today, will never reach us. The galaxy is still there, still exists, but it has effectively left our universe. We are seeing its past. We will never see its future. And the number of galaxies in this situation is growing. The accelerating expansion is sending more galaxies across the event horizon every billion years. Our observable universe, in terms of what we will ever be able to receive new information from, is shrinking. Let's follow this forward in time. Right now, our observable universe contains approximately 2 trillion galaxies. 2 trillion. The night sky, even to the naked eye, hints at this richness, the Andromeda galaxy visible as a faint smudge. The Milky Way's own band of stars suggesting a much larger structure. In approximately 150 billion years, all galaxies outside our local group, the gravitational cluster that includes the Milky Way and Andromeda, will have crossed the cosmic event horizon. Their light will no longer reach us. They will be effectively invisible, gone from our observable universe permanently. By that point, the Milky Way and Andromeda will have already merged. In approximately 4.5 billion years, Andromeda is heading toward us at around 110 kilometers per second, The two galaxies will collide and merge into a single elliptical galaxy that astronomers sometimes call Milky. This merger will be the last major addition to our local universe. Everything else, the hundreds of billions of galaxies currently visible, will have receded beyond recovery. Now imagine a civilization, not human, born in this merged galaxy a trillion years from now. They are intelligent, they have telescopes, they are curious about the universe. They look at the sky, and they see their own galaxy. Stars in every direction, a rich, complex home galaxy. And then, nothing, empty space as far as their instruments can reach. No other galaxies, no cosmic web, no clusters, no structure beyond their own. They study their sky carefully. They develop physics. They build theories. And their theories tell them something that, from our perspective in 2026, is devastating. They conclude that the universe consists of a single galaxy surrounded by void. They believe they are alone. That there is nothing else. That the universe is small, simple, singular, and every single conclusion they reach will be wrong. 2 trillion galaxies existed once, but the evidence left the observable universe before they were born. There is no way for them to know. No fossil, no signal, no trace. The universe will have hidden its own history from its future inhabitants. Now bring that thought back to 2026. Back to us. We are living in what cosmologists have called the golden age of cosmology. Right now, today, we have access to more of the universe's history than any civilization that will ever exist after us. The CMB is still visible. The cosmic web is still mappable. 2 trillion galaxies are still detectable. But the window is closing. Slowly, on human timescales. But closing. The universe is not revealing itself over time. It is concealing itself. And here is what science still cannot fully explain. We know the universe is accelerating. We observe it. We have confirmed it across multiple independent measurements. But we do not know why it is accelerating. Dark energy, the label we give the force driving this acceleration, is a placeholder. A name for something we cannot see, cannot measure directly, and cannot explain from first principles. Dark energy makes up approximately 68% of the total energy content of the universe. It is the dominant force shaping the future of everything. And we have no confirmed theory of what it actually is. The edge of the observable universe is real. The shrinking is real. The loss of galaxies is real. The reason it is happening is still one of the greatest unsolved problems in all of physics. We live inside a universe that is actively hiding itself. Galaxies we can see today will be invisible to future eyes. Evidence of our cosmic history is being erased in real time. And the force responsible, dark energy, remains one of science's deepest mysteries. Scientists are still searching for the answer. The next time you look at the night sky, remember this. Every galaxy you can see is a gift. Ancient light that made an impossible journey. A message from something that may already be beyond our reach forever. We are the last generation of the universe that will be able to see this much. Everything after us will see less. Subscribe to Binge Time for the next episode. And comment one word below. What do you feel right now? We will see each other in the next video. Until then, happy binge time.